Have you ever pondered why a toaster gets hot while your phone stays cool, even though they're both using electricity? Or perhaps you've wondered what allows electric cars to accelerate from 0 to 60 miles per hour in just a few seconds. Well, the answers to these questions and many more lie in the understanding of two fundamental concepts: Ohm's law and supercapacitors. Ohm's law is a cornerstone in the world of electronics. It's a simple yet powerful principle that governs how electricity flows through a circuit. Named after the German physicist Georg Simon Ohm, this law states that the current passing through a conductor between 2 points is directly proportional to the voltage across the 2 points. In simpler terms, if you increase the voltage, the current increases proportionally and vice versa. It's like water flowing through a pipe. The higher the pressure, the more water flows. Supercapacitors, on the other hand, are energy storage devices that can store and release electrical energy very quickly. Unlike traditional batteries, which store energy chemically, supercapacitors store energy electrostatically. This allows them to charge and discharge rapidly, making them ideal for applications that require high-power bursts, such as electric vehicles. So how do Ohm's law and supercapacitors relate to each other? Well, the ability of supercapacitors to rapidly store and release energy aligns perfectly with the principles of Ohm's law. When a high-power burst is needed, the supercapacitor can quickly discharge, providing the necessary current to meet the demand. And when the demand decreases, the supercapacitor can recharge just as quickly, thanks to its electrostatic energy storage mechanism. In conclusion, understanding Ohm's law and supercapacitors is crucial for comprehending the behavior of electricity in various applications. Whether it's the heating element in a toaster or the acceleration of an electric car, these concepts play a vital role in shaping our modern world. So next time you use an electrical device, remember the principles that make it all possible: Ohm's law and supercapacitors. Now imagine you could store this flowing electricity and use it when needed. That's where supercapacitors come into play. Supercapacitors, also known as ultracapacitors, have the ability to charge and discharge rapidly, storing a significant amount of electrical charge in a small volume. They are like quick-charging energy reservoirs. Unlike batteries, which use chemical reactions to store and release energy, supercapacitors store energy physically, which enables them to charge and discharge in seconds. But what makes supercapacitors so super? The secret lies in their structure. They consist of two metal plates coated with a porous material like activated carbon. This design results in a high surface area for storing electric charge. When voltage is applied, ions in the electrolyte solution rush towards the plates, clinging to the surface and storing energy. When the voltage is removed, the ions rush back into the solution, releasing the stored energy. This rapid charge-discharge cycle is what powers our electric cars, providing that instant burst of speed. In summary, Ohm's law is a fundamental principle that defines the relationship between voltage, current, and resistance in an electrical circuit. It's the rule that explains why a toaster gets hot and your phone doesn't. On the other hand, supercapacitors are high-capacity components that store and release electrical energy quickly. They're the magic behind the rapid acceleration of electric cars and the quick charging capabilities of many modern devices. These two concepts, Ohm's law and supercapacitors, are more than just theoretical ideas. They are the driving force behind many of the electronic devices we use every day. So next time when you switch on your toaster or step on the accelerator of an electric car, remember you're experiencing the practical application of Ohm's law and the power of supercapacitors.